Hey guys, it's Rishi once again, and today we're back with compound measures. But what are compound measures? Well, these are types of measurements that involve two or more different units. And examples of compound measures include meters per second, grams per centimetre cubed, or even population per kilometres squared. And so what we'll be focusing on today is many of these. In particular, we'll have our speed, our distance, and our time. So I think for this particular topic, the best way is to dive into this right away. Now, we have an equation triangle. That is a tool that can be used to help rearrange equations. So I will be going through those as we go through each question in detail. So let's start off with question number 1. A sprinter runs a distance of 200 meters in 25 seconds. So work out the average speed of the sprinter. So this is where the first triangle comes in. And within this, we have three main areas. The first is our distance. The second is the speed. And the third is time. So now, what do we have in this particular question? We have our distance, which is 200 meters. So we can put that there. And we have our time, which is 25 seconds. So we now know if we cover up speed with our finger, we'll have distance divided by time. So 200 divided by 25 is 8 meters per second. So we have 8 as our first answer. So I hope that was clear, and I hope you can see how we can simply create this triangle to solve our question. Okay, question number 2. A block exerts a force of 120 newtons on the ground, and the block has an area of 2 meters squared. Work out the pressure on the ground. So we start off with our force, which is 120. We have our area, which is 2 meters squared. We divide that and get 60 newtons per meter squared. And there we are. So we're simply substituting the values in the correct areas to get our answer. Once again, I hope you can see how we're working with newtons and meters because they're two measurements. These are called compound measures. Okay, question 3. A piece of gold has a mass of 760 grams. So now we're working with your mass, your volume, and your density. So these are the three key areas that we need to work with: mass, density, and volume. So it's got a mass of 760 grams, volume of 40, and we need to calculate the density. So again, for this particular question, let's have our density, which equals our mass over the volume. So we'll take our mass, which is 760 grams, and divide this by our volume, which is 40, and that gives us 19 grams per centimetres cubed. And there we are. So the key area here is to familiarize yourself with these equations. So the next time you're faced with a question like this, you're aware of which equation to use. Okay, question number 4. A rock has a mass of 58 grams and a density of 3.5 grams per centimetres cubed. So let's work out the volume. So again, very similar to the question that we've just done. We'll have our density, mass, and volume. I'm now going to go ahead and show you this using the triangle. So we'll have our mass, we'll have our density, and our volume. And now we need to work out the volume, which means I need to make that the subject. So if you just put your finger over volume, you will be left over with mass and density. So again, if I just use my black cursor here and I cross this out, you're left with mass over density. And that's the easiest way to rearrange your formula. So now we'll take our mass, which is 56 grams, and divide this by 3.5, which will then give me 16 centimetres cubed, and that is my answer. So I hope that was quite simple. Let's now go through question 5. And remember, practice makes improvement. So if you're still not sure or comfortable with this topic, that is absolutely fine. It will take you time to go through and understand each and every concept. So for question 5, we know that we are working with our distance, our speed, and our time. So let's write out our speed, which equals distance over time. And I've made it equal to speed because that is what we need to work out. So we'll get our distance, which is 230 miles, and I'll divide this by our time. But before I write out my time, I'm going to convert this to a decimal, which will be 4.25 hours. So we'll have 4.25. And if we put that into a calculator, that will give us 54.1. And that is our answer. So we now know that this car is traveling 54.1 miles per hour. And all I've done is simply divide my distance by my time. Okay, let's move on to question 6. Feel free to pause the video at any time and attempt the question before you press play and go through the solutions. Okay, a block exerts a force of 84 newtons on a table. So we have our force, which is 84 newtons. And we know that the pressure is 30 newtons per meter squared. So we need to calculate the area. So again, step 1, I have just substituted everything that I've been told. I know the pressure is 30, so I've gone ahead and put that as 30 as per the formula. I then know that the force is 84 and I know my numerator is 84, so I've also done the same here. So all we need to do is rearrange the formula to calculate our area. So we have a divided by area right now. If we take it to the other side, it will become a multiply. And the 30 will then swap in its place. So we now have 84 over 30, which equals 2.8 meters squared, and that is our area. So again, I've just swapped the 30 and the area over, and I've got my answer, which means it's going to be area equals force over pressure. Marvellous. Okay, question 7. The liquid has a density of 1.3 grams per milliliters, and we need to now find the mass. So for this question, we'll have our mass, which equals the density multiplied by the volume. So our density is 1.3 and our mass is 250. So if we multiply that together, we will now be given 325 grams. And there we are. Marvellous. Let's go for question 8. Danny leaves her house at 8 a.m. and she drives 63 miles to work. And she arrives at an average speed of 27 miles per hour. So what time does Danny arrive at work? So again, we're working with our distance, speed, and time here. So distance, speed, and time, I've just written that out. We now need to make t the subject. So if I cross t out, we'll have distance over speed. So we'll have 63, which is our distance, speed, which is 27, which then gives us 2.3, and that's occurring. And that's going to be your hours. So now we need to work out what 0.3 hours are in minutes. And that's there going to be 2 hours and 20 minutes. And the way I did that was simply take 1/3 of 60, where I divide the denominator and then times the numerator, and I roughly got about 20 minutes. So if we leave at 8 o'clock and it takes us 2 hours, 20 minutes, we know altogether, if we add 2 hours plus 20 minutes, that will give us 10:20, and there we are. Marvellous. So I hope that question was clear. Let's now move over into question 9. So Anthony travels from Newcastle to Manchester at an average speed of 65 miles per hour. The journey takes him 2 hours and 15 minutes, and Declan makes the same journey in 2 hours and 35 minutes. So let's work out Declan's average speed for the journey. So again, we'll draw out our equation, and that's your distance, speed, and time. We will then convert 2 hours 15 minutes into a decimal, which is 2.25 hours. And let's start off with Anthony. So with Anthony, we have his average speed and we have the time, but we don't have the distance. So with speed times time, that will be 65 multiplied by 2.25. So now I know that my distance will equal 146.25 miles. But now for Declan, he makes the same journey in 2 hours and 35 minutes. So we've now worked out the distance that they're both doing because they have the same journey. And now we are working out Declan's speed. So we have the distance and we have the time. The distance is 146.25 and we have his time, which is 2 hours and 35 minutes. So what I simply do is I convert it into minutes. So we have 2 hours, which is 120 minutes, plus the 35, and that's 155 in total. I then go ahead and divide that by 60 minutes, and that gives me 2.583 recurring. So now I know that my time will be 2.583. And when I put that into the calculator, I now know that Declan's average speed will be 56.6 miles per hour. And there we are. So this is a 4-mark question. Let's go ahead and see exactly what I've done here. So I started off by calculating the distance for Anthony. I was then told that Declan makes the same journey, so I can use the distance for Declan as well. And we needed to calculate the average speed. So then I divided my distance over time to get my speed, and that gave me the speed of Declan. Marvellous work. Let's now go for part B. So if Declan took different roads than Anthony, how could this affect your answer to part A? Well, let's think about this. If the distance was increased, let's say he takes 2 different roads, if the distance was increased, then the speed would be higher, right? But if the distance decreased, then the speed would be lower. So it totally depends on the distance. And there we are. And that's your 1 mark in the bag. Marvellous. Okay, you're doing really well by coming this far, so let's keep up the great work. And let's dive into question 10. So Rachel drives 300 miles from London to Newcastle. She drives the first 165 miles at an average speed of 60 miles per hour. And from this point, it takes Rachel 3 hours and 15 minutes to complete her journey. So what was Rachel's average speed for the whole journey? So let's go ahead and draw out our triangle and do distance, speed, and time. We're now going to base this on the first 165 miles. So we have her distance and we have our speed. So we'll have 165 divided by 60, which then gives us 2.75 hours. So that's our time. And if we convert that into hours, we will now have 2 hours and then 3/4 of an hour, which is 45 minutes. And then from this point, it takes Rachel 3 hours and 15 minutes to complete her journey. So if we add that to 3 hours and 15 minutes, in total, that would give us 6 hours. So now we have our total distance for the total journey. And now we need to calculate the average speed for the whole journey. So we're going to take our total distance, which they mentioned was 300 miles, and we're going to divide this by 6 hours, which then gives us 50 miles per hour. And that there is her average speed. So again, I hope you can see how I've calculated the first 165 miles by dividing my speed by my distance. And then when I get my time, I put it together to calculate the total time it's taken to complete the journey. And then I've divided this by the time it's taken to get my average speed, which should be 50 miles per hour. Marvellous.
Okay,
Let's move over to question 11. We're almost there, so keep up the great work. Andrew ran 3.1 miles in 14 minutes and 35 seconds. And he assumes that he can run 8 miles at the same speed. So work out how long it would take Andrew to run 8 miles and give your answer in minutes and seconds to the nearest second. So again, I hope you're getting an understanding of these sort of questions and when to use which equation. So we know now that we are going to be following our speed, our distance, and our time. So let's start off with what information is being given to us, which is our distance, which is 3.1 miles, and we have our time, which is again 14 minutes and 35 seconds. So again, please remember to convert this into a decimal, you need to divide it by 60. So when I've done that, I get 14.583 recurring. And that answer would give me 0.21257, and that's miles per minute. And remember here, this is my distance over my time. So that's on the basis of Andrew running 3.1 miles. But now let's do this on the basis of Andrew running 8 miles. And if he says that he can run this at the same speed, then we know that we can have 8 as our distance divided by our speed. So distance divided by speed would give me 8 over 0.21257, which then would give me 37 minutes and 38 seconds. And that is my answer. 37 minutes and 38 seconds. So let's take a look at what I've done here. I've started off by working out the speed for Andrew, running at 3.1 miles in 14 minutes and 35 seconds, so distance over time. I've then gone ahead and worked out the time that it takes Andrew to run 8 miles at the same speed. And again, I've used my answer for the same speed, substituted it in, and it's given me 37 minutes and 38 seconds. And there we are. But now part B there asks us that Andrew's speed actually decreases the further he goes. Now, how does this affect your answer to part A? Well, if his speed is decreasing, then it's definitely going to take him longer to run the 8 miles. So the answer there would be higher. And there we are. So let's now move over to question 12. So this is a question around density, mass, and volume. So again, we'll write out our mass, our density, and our volume. Now they've given us the density of liquid A, and they've told us that liquid A and B is mixed to make liquid C. And liquid C has a mass of 210 grams and a density of 1.12. So find the density of liquid B. So let's take a look at liquid A. We know we're going to have our mass, which equals density times volume. We know our density is 1.2 and our volume is 150. And that there would give us 180 grams as our mass. We then have more information about liquid C. So we know that liquid C's volume is what we need to calculate. And so we have our volume, which equals mass divided by density. So that means our mass is going to be 210 and our density is going to be 1.12. So if we divide that together, we'll then have 187.5 centimetres cubed. And that is our volume. But let's not forget that liquid A plus liquid B gives us liquid C. But because we have liquid C and liquid A, we are going to reverse that And in order to calculate the volume of liquid B, we are going to have liquid C take away liquid A. And that's going to be in the terms of its volume. So liquid A's volume is 150 and liquid C's volume is 187.5. So if we subtract that, we are left with 37.5 as the volume of liquid B. Let's not forget we need to find the density of liquid B. So now we've calculated the volume of liquid B, let's calculate the mass of volume B. And again, by doing the same thing. So liquid B, let's go for liquid C, take away liquid A. But this is now for our mass. So let's write volume here, and let's write mass just below. So on that basis, we have the mass of liquid C, which is 210, subtract the mass of liquid A, which is 180, and that gives us 30 grams, and that's the mass of B. So now all we need to simply do is use our formula because we have our volume and our mass. So again, if we have the volume and the mass, we know it's going to be mass divided by volume to get our density. So we'll take our mass, divide it by our volume, and that would give us 0.8, which is then our density. And that is our answer. So let's go ahead and recap what we've done here. We've gone ahead and calculated the mass for liquid A and the volume for liquid C. And now we have all three parts for each specific liquid. Once we've gone ahead and done that, we can subtract liquid A from liquid C, which then would allow us to calculate what is left over for liquid B before then calculating its density. So I hope that was useful. It will take time for you to understand, so feel free to pause the video at any time, attempt the question, and then press play to go through the solutions. And you can watch this more than once. Remember, practice makes improvement, so don't give up. And that brings us to the last question now. So I need your full attention here. And let's see if we can attempt this question by pausing the video. Okay, for those who would like to go through it, let's do so right away. So we have 100 milliliters of liquid A and 200 milliliters of liquid B that are mixed together to make liquid C. 100 to 200, that's your A to B. And now liquid A has a density of 0.7 grams and liquid B has a density of 1.1 grams. So let's work out the density of liquid C. So again, I'm going to start by doing my mass, density, and volume equation. We now have our liquid A as our volume and as our density, and the same for our B. So let's go for liquid A, and we need to calculate the mass, which is going to be our density times our volume, and that's going to be 0.7 times 100, which is then 70 grams. We'll do the same thing for our liquid B. We'll have 1.1 times by 200, and that will give 220 grams. So now we need to calculate the density of liquid C, which will then be our total mass, which is 220 plus 70, divided by our total volume, which is going to be 100 plus 200, and that gives us 290 over 300. And if we put that into the calculator, that will then give us 0.96 grams per milliliters. So now we know that the total density of liquid C is 0.96 grams. And remember, the reason why I had to add all of this together is because it states that liquid A and B are mixed together to make liquid C. So that gives our answer as 0.96 grams per milliliter. Or alternatively, you can simply simplify your fraction by crossing out a 0, and that is 29 over 30. Marvellous. And that there brings us to the end of our compound measures. I hope this topic was super useful, and I hope you've been given a range of different examples of compound measures where we have distance in time, or having our meters per second or kilometers per hour. Remember, different measures have different sizes. So 10 kilometers per hour is not the same as 10 meters per second. So I hope this video was useful. Don't forget to comment and share our videos. And if you have any other feedback for me, don't forget to comment below so I can then work on that feedback to help you in the future videos. With that in mind, have a great day and I'll see you in the next video.